So today we're going to talk about the chip here, which is the PA1517 by Unisonic. I bought this chip because, well, I bought a bunch of these chips because I need to incorporate a little audio amplifier into a project that I'm building. And I didn't want to go with a digital amplifier because usually these are fairly complicated from a layout perspective, and often also the performance isn't quite as good. And it is a battery powered product, so Class D amplifier would be nice, but then again, this if you have it under the right conditions, this is the chip, by the way, it comes up to about 70% efficiency, which it's okay. 70% efficiency is alright. I don't mind that at all. Also, you get rid of a whole bunch of design complexity. If you look at this is straight out of the data sheet. Typical application, you just need to add. You don't even need that filter capacitor if your supply is filtered nicely. So you add 1, 2, 3, 4, 5, 6 capacitors, and presto, there you are. Got yourself an amplifier. In terms of pin layout, this is actually, you can have this chip, where did I have it here? You can have it in a couple different packages. This is the DIP 18 version, but there's also a DIP 20 version, and there's a single inline version, which is very attractive, but they didn't have these on LCSC. So I bought the 18-pin DIP. These are a little pricey at 27 cents in 10 quantity, and gets down a little further if you buy more. But then again, 25 cents for a rather nice, simple Class B amplifier is pretty good. I don't mind that at all. So the pin layout on this is such that one side is ground and basically the heatsink. So that's another great thing about this chip is you don't really need to heatsink it. With a lot of other Class B amplifiers like this, I had some over here actually, but well, this is not a Class C amplifier, but a Class B amplifier. But often they come in cases like this, in transistor packages, and then you need to bolt them to a rather large heatsink. With this, you can actually sink away most of the heat, I think, with putting a bit of a ground plane behind it, so to sink it away via the pins, which is nice. And I like to breadboard circuits like this if I'm evaluating a chip. But since it had that sort of awkward layout where you had, on a breadboard, you'd have to jumper over 10 pins. Well, 9 pins. But so I just put it on a little bit of proto board here. And just to go over the components here real quick, and then we'll do some measurements on this circuit. This is the power supply. Basically, it has this filter cap, then 2 of these hooks for the power. This is the output side with the 2 largest capacitors where the speakers connect. Speakers connect to these hooks, and then I've got the 1/2 VP filter cap. This one here, and then 2 200 nanofarad input caps here, and also this connects via these hooks. Actually, I was a bit bold on this one. I just common single ground, power ground, all the grounds that I had. I just common them all together, and it works fine. It actually sounds good. I don't mind it at all. So I think the thing to do next is to take this demo board and then just hook it up to some test speakers. These just connect to some banana plugs and then some crocodile clips here. I'll just have to. They're actually meant to be used with those hook probes, not crocodile clips, so this is a little awkward, especially because these are large. Right, I'll change this over. So this is much better. And we'll just test this mono for now. The supply range on this is from 6 to about, I think, 18 volts. So, but it's really designed to be run around 12 volts, I think. So that's what I'm going to do. And that also fits in nicely with the project I'm building. So I'll just get this cheapo multimeter here because it has a built-in square wave function generator. And we'll hook this up here. As you can see, there's also no shielding on any of these lines, so this is a good test for noise immunity. And now the last thing to do is to hook up 12 volts power here and here. And I don't think you can actually hear that. It's slightly humming, but it's really not all that audible, so that's great. If I touch this, obviously you can hear it hum. So let's just do a quick sort of frequency sweep here. Oh, this is this will kill headphone users. Honestly, it will just. So this obviously doesn't work. We'll just have to put a little attenuation on there. 1 second. So to remedy this, I just put a 100k pot in there, so I can actually turn down the volume a little bit. So we go again at 50 hertz. This is a square wave that's actually surprisingly clean for what this multimeter costs. I'll just go up to 100, 200, 300, 400, 500. And still at 5 kilohertz, this is working reasonably well. I think we'll go down to, well, I'll just turn it off for now. And I think the thing to do next is to measure its current consumption. This is still only one channel, so the current consumption would obviously be double if we're actually using both channels. So I'll get my multimeter here, put it into amps, and then this is actually still only very slightly warm. There we go. Its quiescent current draw should be between 40, which is typical, and 80 milliamps, so I think we're pretty much in spec there. especially because this is not really quiescent, because there's still signal coming in. We haven't attenuated it down all the way. So let's just see what this does. So this is 60 milliamps. It's pretty loud, actually. This is actually already a level at which it is very uncomfortable to listen to 50 Hertz. Let me just do that again with... My dad uses a little more. Or I just turned it up louder. And we'll do that at 5 kilohertz again. Yeah, I think there it distorts a little at the high volumes. Yeah, but I'd say this is a success. It doesn't take all that much current at 12 volts. That's something like maximum 400 milliamps, 500 milliamps. Is 6 watts, and that's what it's spec'd for. It's 2 times 6 watts. So I'm pretty happy with that. I think the last thing I'll do now is I'll actually play some music from it. So I think it's time to test it under some real-world conditions by playing the most overused song in the YouTube audio library that I could find. It's hooked up to this weird contraption here, which is just a Bluetooth receiver hooked up to an adapter, hooked up to an adapter, hooked up to 2 crocodile clips, hooked up to one of these hook probes and going in there. So signal integrity is key here. And noise immunity. So let's just hit play here. See what that does. It's not a lot of current draw. Well, it's reasonably loud though. It sounds pretty good too. I mean, I don't mind that at all. Come on, stop playing. Yeah, I think I'll definitely put this chip in my projects. It's a good chip. Also, I don't really have plans for this board. Maybe we'll have a follow-up video where I turn this evaluation board here that I made into a little, I don't know, kitchen, bathroom speakery type of thing. Because I actually think this turned out rather neat. So, yeah. It's so one thing I like about this is the input is a 50 kilo ohm impedance, so it's reasonably low. So you don't pick up all kinds of crap from the air. If you use some of the Class D amplifiers and stuff, and also other Class B amplifiers that have much higher impedance, input impedance, if you leave the input just open, you'll draw in all kinds of noise. I like the chip. It's a good chip.